going to share my screen so you guys are ready to rock and roll. Hey, Andrew. I don't know, Andrew. Can you? Did you see it curve? That's a nice little thing. Yes, you may. I got to tell you, I'm walking over here to tell you this. I thoroughly enjoyed those Milanos. Rocked my face off. They didn't last but about 5 minutes and they were all gone. But anywho, thanks again. All right, let's see now. Warm-ups. Okay, so I know it's been several days since we've had like a legit class, but we're writing down this example. We're going to work things out. Remember, if it's division's multiplying by the R word, reciprocal, and we want to factor. I assumed, but just want to make sure. We're going to factor everything, okay? So, I mean, literally just go through and see if you can factor all 6 sides, and then we're going to cancel out and simplify. Yeah, definitely have to flip before you start canceling factors out. Hey, Peter, what's up, bud? Jack, now that Gabriel is gone, you can resume your normal location. That way I'm not thinking, I know Alden's out today, but I'm only missing one from y'all's row. And let's see here, Johnny, Alden, Henry, and Andrew. Johnny, Alden, Henry, and Andrew. So there's 6 of you I'm fixing to call on, and you're going to hook me up with a little factorizations. All right, a little factorization. Vinny, factor the top left. Vinny, what do these 2 terms have in common? Oh, thank you, Grant. I always depend on you. Thank you. Vinny, what do those 2 terms have in common? Try again. They just have a 3 in common. I wouldn't recommend taking out the negative unless that first, leading term was negative in and of itself. Well, we'll cross that bridge when we get there, big boy. X minus 2. All right, thank you so much. Let's see here, George, bottom left. Did you throw the baby out with the bathwater? Thank you. 4 and then x minus 1. Now, multiplication, Jude, that means don't flip, correct? All right, so factor the top one of the middle fraction there. X plus 3. Beautiful. X minus 1. All right, Will, factor the bottom of that middle fraction, please. Fabulous, thank you. And I love how this was a good illustration. As Jude and Will were both answering me, you can see the wheels turning, right? We're going through, and at this point, we're checking factor pairs. And we're looking for factors, whether it's factors of -3 that add up to +2, or factors of -10 that add up to -3. That's what we're doing. That's what we're looking for. All right, now, Sam, what do I have to do before I factor that last fraction? Flip it because it was division. So I'm going to flip it, and so Sam, I'm going to ask you, it was the original fraction's denominator. Now it's going to be my new numerator. Go ahead and factor that out. So in other words, factor this guy for me. 8 times the quantity x plus 2. Beautiful, beautiful. Okay, and then let's see here. Jack, you want to do the, now this was originally the numerator, but I'm going to have it on the bottom since we're flipping it and changing multiplication. Factor that one out. Nope. The one I've got circled in green. That's okay. You don't need to apologize. So yeah, and again, you can real quickly check yourself as you guys are doing these, just with a little distribution as needed. Okay. Ben, pick me something that you want to cancel out. Just one pair, please. Okay, very nice. Gregory, pick another pair. That's all good. Okay, and then let's see, Andrew, you want to do another cancelization? I'll give you a hint. Babies. He's like, what the dump does babies have? Well, I was telling somebody not to throw the baby out with the bathwater. That's what I've been referring to with my GCFs. Look at your numerical factors. Well, we could. 3 times 8 is 24. What would you do on the bottom? 4 times 2 is 8, and 24 over 8 is going to leave me with 3 on the top. We could, at this point, does everybody understand that we could do that? Like, that's not going to be taxing our mental processes very much. But if I wanted to be consistent and continue to cancel things out, like I could cancel out a 4 with that 8 and be left with a 2, and then I could cancel out that 2 and only be left with my 3. You see what I'm saying there, fellas? It's either way, whatever floats your boat, you could do it. But we just want to be cautious about maybe trying to multiply big numbers first. It's always easier to simplify in those cases. I think we've canceled everything, so let's write up our final answer here. We got a 3, we got an x minus 2, we got an x plus 3 on the top, and we got an x minus 5 and an x plus 6 on the bottom. Benny.
You do only the first with the x up in the.
What are you saying now?
Because what do you, like when you're canceling something out, what do you start with the left, and once you have that.
Oh, I see what your question is now. Once we've got everything written as a big strand of multiplication, because multiplication is commutative, like we could rearrange our factors all across the top wherever we'd like. You know what I mean? You can cancel whatever way you want. You can cancel, like I think Gregory, when I asked him, we canceled out this x plus 2 and this x plus 2. If this had been an x plus 2 up here, we could have canceled these 2, or we could have canceled those 2, whatever way we wanted to do it. Fabulous question. Again, multiplication is commutative, so feel free to cancel as you like. And somebody else had a hand up, maybe. Feeling pretty good about this little warm-up question? Putting it all together as far as multiplication and division is concerned. We're going to shift gears. We're going to talk about 2 vocab words from the first semester. Whoops. Okay. Domain and range. All right. So this is new for us today. New part of this lesson. Talk about the domain and range of a rational function. A rational function, remember, that's just a fancy way of saying fraction, where the top is a polynomial and the bottom is a polynomial. Okay. And remember, I say that the domain's a set of inputs. What letter does that usually pertain to? Try again. X. And then the range would be our set of outputs. What letter does that usually pertain to? That a kid. Okay, so inputs are usually X, outputs usually Y. So domain is a set of X values, range is a set of Y values. Okay. And then I give you a nice little how-to. I pulled this from the text. If you're that kind of guy where you like step-by-step process, you can jot those down. Really, it's going to be a matter of, okay, remember, where does a fraction equal 0? And where is a fraction undefined? Okay. Now, I am actually, hey, Coach Newman.
Hi, just quick. We're so good for this.
Absolutely, we are. Looking forward to it.
You want to meet and go?
Yes. What off periods do you have?
You've been through.
Well, I didn't know if you had changed anything.
I'm just not.
I got you, man. Thank you. I'm looking forward to it. let's see here. I'm going to add like a little Coach Morgan preference flavor into these steps. And I'm going to say at the first step I usually like to do is I go ahead and try to factor everything. That's just my inclination. You certainly don't have to do it that way, but I recommend going that approach. Okay, so check this out. Here's what I would recommend doing first. Factor the top. Get my pen to work. Come on, pen. Good grief. Maybe my battery's getting low. We'll blame Coach Newman. It was working before he came over here. Plus sign, plus sign. There we go. All right, factor the top. Take out a 2x, and we're left with an x minus 7. Factor the bottom. Take out a 4. And then what are we going to have? I'm going to have to, I can't think too many steps ahead. That's 12. What do y'all think? Between negative 12 and negative 4, is it going to be negative 6 and positive 2? X plus 2. Y'all can double check me on that if you'd like. But I prefer when I'm looking at a rational function, go ahead and try and factor the top and the bottom. Could you make that additional note in your little step-by-step process there? Factor the top and bottom. Now, at this point, okay, if we were to set the denominator equal to 0, how many solutions would we get, Ben? We get 2. It's a quadratic denominator. It's going to be 2 roots of the denominator. Quentin, what are those 2 roots? It is. All right. So the roots of the denominator here, x equals 6 or x equals negative 2, would make this function undefined. Okay. So in other words, good morning, Alden. In other words, f of 6 is undefined. F of negative 2 is undefined because if I tried plugging in 6 into this denominator, I'm going to get out a 0. I'll show you what I mean. Okay, you don't necessarily have to run these numbers, but f of 6, for example. Okay, so that's 2 times 36, that's 72 up top. 6 times 10, that's 60, 84, so minus 84. And then we're just doing a little arithmetic. 6 squared is 36, so that's 144. 6 times 16 would be 76. No, 96, I think. 96 minus 48. What's that going to wind up being? Negative 12 over 0. And what's negative 12 over 0? Yeah, undefined. You can't divide by 0. And so 6 is going to be what's called a restriction. All right, we're saying that x cannot equal 6 for this function. So when we talk about the domain, all right, it is the set of x values, remember, the set of x values that you're allowed to plug in. And so the only restrictions from our domain is going to be this 6 and this negative 2. Anything else is legit. Anything else I could plug in. So here's how we would describe the domain. And this will be the last little bit as it pertains to this example. The domain, we would say x is a member of the set of real numbers. X could be anything you want, except x cannot equal 6 or negative 2. Okay? So x could be any real number that you'd like, except these 2 restrictions. We would have to say, sorry, those you're not allowed to plug those numbers in. Okay? Now, in Algebra 2, you'll study further. You'll talk about range. You'll talk about a whole boatload of stuff. You study rational functions in Algebra 2 quite a bit. But the only thing that you're required to come into Algebra 2 in a couple of years, or a year and a half, already knowing is how to do what we did, which is to factor the top and the bottom, Notice that nothing cancels. Really, I guess the 2 and the 4 could have canceled, but that didn't really change our domain. And then look for restrictions on the function. Restrictions keep you from dividing by 0. Okay, so you're not allowed to divide by 0 in that case. Any questions at all about that example, Jack? All right, good question. So that's from our ZPP. Let me zoom in over here. The zero product property tells us that when you've got a product that you're considering setting it equal to 0, you would say, all right, well, each individual factor equals 0. So for example, if x minus 6 were to equal 0, I would have to add 6 to both sides to solve that, and I would get x equals positive 6. And then similarly over here, you would do the same thing with x plus 2 equals 0, and subtract 2 from both sides, and x equals negative 2. So those will be the 2 solutions when setting the denominator equal to 0. All right, good question. I like that. Anybody else? Luke, you look like you're struggling to stay awake. You okay? Gregory?
Where does that 4 go when you do the 0 product?
Good question. Does 4 ever equal 0? And that's okay. So 4 equals 0, and no solution to that part. But because you're considering there's an or between all of these, that's okay. You would just say, it's a numerical GCF. It didn't provide me with any kind of answer. George?
So if you're looking for the range, would you do the same thing for the denominator?
No, that's a great question. I said we'll have to wait for a little bit on the discussion of range. It's because I'd have to teach you a whole big fat lesson on how to find horizontal asymptotes. You could go on like a website called Desmos, or you could get out a handheld graphing calculator, and you could put down a graph, and the graph would look something like this. Positive 6 and negative 2. And the graph would, I'm going to ballpark it here, would look something like this. Now it's going to have, anyway, this is a crappy graph, but it would look something like that. And so the y value, talking about the range, figuring out the y values, there are some restrictions, and it would just depend on how high this went and how low that went. But you don't have to know that in Algebra 1. That would be grossly unnecessary for this age group. All right, tally ho. I'm not going to give you a quiz today. Okay, I'm not going to give you a quiz today. But if I did, here's what it would look like. Okay. So again, am I giving you a quiz today? I am not going to give you a quiz today. But if I did, here's what it would look like. It would be a question about simplifying. It would be a question about multiplying. And it would be a question about dividing. Okay. The hardest thing about a quiz like this, I'm not going to say would, I'm going to say will be whether you can factor. Plain and simple, whether you can factor. Okay. I was telling my little 8th graders, my youngsters this morning, let's see, where are my 2 orange stars? They're several days behind you guys, so they're just now learning the ZPP. And look at where I put the little orange stars, and then I'll get you. Look at where I put the little orange stars. I told them, I said, look, this is going to be the hardest part for you. It's not applying the ZPP, it's factoring. It's remembering how things factor, using the magic method on the first one and the difference of 2 squares on the second one. The same thing when you guys have, whoops, wrong chapter. The same thing when you guys have your quiz on this topic. It ain't going to be the can he cancel. It's going to be can he what? Can he factor? Can he write the top and the bottom as a product? Will, you had a hand up. Oh, certainly. Okay. Everybody understand what we're saying here? I want you to succeed. So practice factoring. In other words, go back to Delta Math and be practicing, going like crazy. No, what you had last week was like legit as far as multiplication and division goes, right? But what we're going to start today is we're going to start adding and subtracting. Okay, this is a new section. This is section 7.2. Okay, section 7.2 is about adding and subtracting. Now, let me, a little word of caution for you, okay? When you're in elementary school, let me paste this in, there we go. When you're in elementary school, what do you start with? Add, subtract, multiply, or divide? You start with adding. Even before you learn subtraction, you start with adding. Adding and then subtracting, and then you learn multiplication division later on. Because it's a little bit more of a complicated process when you're talking about numbers. When you're talking about fractions, the reverse is true. We started with the easier multiplying and dividing. Gavin said a moment ago, that looks easy. It is. Multiplying and dividing is very easy. Adding and subtraction, not so much. Okay? And I'll ask one question and you'll remember why. What do you have to add fractions? Everybody knows that, right? What do we think? Yeah, common denominator. That's a pain in the you-know-what when it comes to rational expressions, big fat fractions. I'll show you what I mean. Let me just pause for a sec on this simple kind of startup example and consider the fractions 1/2 plus 1/3. If I asked you to do that, could you do that?
Yes.
Absolutely, right? You've been taught how to do that. That's great. You get a common denominator. You would say, let me change this first fraction. This first fraction is the same thing as 3/6. The second fraction is the same thing as 2/6. And therefore, I have 5/6. Okay? If you can do this down here in blue, you can do this example up here in black. It's the same exact process. There's one little thing that was going on behind the scenes, right? What did I do? I multiplied by 3/3, and I multiplied by 2/2. What is 3/3 equal to? And what is 2/2 equal to? That's called the old thing in the middle trick. Technically, it's called the multiplicative identity property. But the old thing in the middle trick, what I refer to is you can always multiply by 1 whenever you want to, in the middle of the problem. Just the whole thing in the middle, I will multiply by 1 again whenever I feel like it. I can do that because it doesn't change anything. Just makes the fraction look a little different, right? So 3 times 1 and 3 times 2, it made the fraction look different. 1/2 is still equivalent to 3/6. But I now have it set to where it can go with its buddy over here. And so this is cake. If you can do what's in blue, you'll be able to do what's in black up there. Okay? Same process is going to apply. You got to get a what first? You got to get common denominator. All right. So what I've got set up here in this first example, I've already given you a common denominator. That's kind of nice, isn't it? So really, all we'll need to do is we'll just add across the top. Let's just add across the top. So we get x squared plus 11x plus 28 all over what? Very good. Please make a note. Please, please, please. Pretty pleased with the cherry on top. Make a note that you don't change the denominator when you're adding fractions. Okay? 1/5 plus 1/5 equals 2/5, not 2/10, not 2/25. I see people all the time. They'll multiply, they'll add, they'll do crazy things to the denominator. You're not changing the denominator. You're only changing the numerator. So when we add across the top, we get ourselves a nice, neat fraction. And then, Caleb, what do you think I might want to try to do to all of my answers in this kind of process? Factor it and see if anything cancels out. Very good. Right? So like when you were kids and you were saying, all right, 1/8 plus 3/8, your teacher would say, all right, little Timmy, add these up. And you say, okay, well, I add across the top 4/8. And if you left your answer like that, would she get mad at you? Yeah, she'd say, dude, simplify your answer. And you say, oh, yeah, that's right. And you'd simplify it down accordingly and say, okay, that's 1/2. Again, if you can do that, then you can simplify what Caleb was talking about. It takes a little factoring. And I think 7 and 4 gets the job done. So x plus 7, x plus 4, and then what do you guys notice we're going to take out? We're going to take out x plus 4. So we get x plus 7 is our answer. Now, hopefully I haven't gone too fast through that. Did I go through that too quickly at all? You guys all right with this? Okay. I need to make one small little adjustment here. Here's my answer. Okay. But I'm going to put in a caveat. What is x not allowed to equal, Michael? What do you think would mess this problem up?
Yeah.
All right, if I plugged in 0, let's see what happens. 11 times 0 is 0, plus 28 is 28. 0 plus 4 is 4. 0 squared is 0. 0 plus 4 is 4. 28 plus 0 over 4 would be 28 over 4, which would be 7. And 0 plus 7 down here checks out as well. So 0 is not a bad number to plug in. Okay? Right? If I plugged in 4, we're getting closer. We're not quite there yet. If I plugged in 4, that's 44 plus 28, that's 72, I think. 4 plus 4 is 8. And 4 squared is 16. So that's 88 over 8, which is 11. 4 plus 11 down here gets, or 4 plus 7 down here gets me 11 as well. Not a bad number. Make that adjustment for me. What do you think? Ben, I saw your hand a couple minutes ago. Ooh, -4. Now, -4 times 11 would be -44. -44 plus 28 would be 16. -16. 0, 0. -4 squared is positive 16. You're supposed to yell at me here and say, Coach, you can't do that. Why not? I'll do what I want. Whatever. You can't divide by 0, though. So the reason that we're going to restrict, who was it that gave me this, Ben? The reason that we're going to restrict our answer, we're going to get into the good habit of saying, hey, this is my simplified answer as long as x doesn't equal -4, because if x equaled -4, it would make your denominator equal to 0, which is undefined, which is bad mojo, can't have it. All right? This is what's called a restriction, okay? Did your parents ever put restrictions on you? Anybody's parental unit ever do that? Teddy loves listening to audio books on my old phone. I have an old iPhone 5S that I literally had for like 8 years. And so finally, maybe about a year or 18 months ago, I got an iPhone SE, a new one that would just work a little bit better. And so I thought, well, I'll gut this old iPhone 5. So I took everything off of it except Audible, and I put all his favorite little audiobooks on there. So he's got all his Harry Potter books. He's got all the Lord of the Rings books. Just a bunch of fun books for him to listen to. Sherlock Holmes, he's got all the Sherlock Holmes stories on there. Some fun stuff to listen to. Anyway, he gets in the habit, though, of listening to that at inappropriate times. Okay? So, like, he'll be riding in the car listening to it, and that's not an inappropriate time. But then I'll try and talk to him, and he'll be like, huh? What? Dadgummit. And then we'll get home, and he'll still be having it on, and I'm like, dude, just you're not listening to me. I'm trying to get him to do something. I'm calling his name, he doesn't answer. Drives me nuts. So anyway, once in a while, I'll have to restrict him on listening to his audiobooks, right? So I'll just take the phone away, put it in my drawer. I'll say, all right, I'll give it back to you tomorrow. Okay, that's an example of a restriction. It keeps him from listening to his audiobooks. All right, you know what I'm saying? Do y'all parents do something similar to y'all every now and then? Maybe take away like the Xbox, take away the cell phone.
Yeah, that's it.
Yeah. See, for you and Halpern y'all are commiserating. It looks like you know what I'm talking about. Anyway, my point is a restriction keeps you from doing something. In this case, it keeps you from dividing by 0. Okay. So anytime you provide me with a simplified answer, I want you to get in the good habit of thinking about what would my restrictions be for that particular problem. Okay? Do you have a hand up?
Yeah. Would it be wrong if you did put a restriction?
Not necessarily, but I'm trying to teach you a good habit, right? A good habit. So like if you had written, what was it, x plus 7? No, yeah. If you had written x plus 7, you would have gotten full credit. Everybody would have known what you were talking about. But if the instructions had gone a step further and said, hey, simplify this fraction, list any restrictions, then, it's plain as day. You're like, okay, let me list these out. But that's what they mean by restrictions, okay? Is any number that would make the denominator equal to.
You just like check to see, like, sketch and check.
No. A good question. Let me show you what I'm talking about. You and I just got through looking at, there it is, that step-by-step process for how to find your restriction. I didn't say it back on this slide, but this slide could be titled How to Find Restrictions. You know what I'm saying? So in other words, I take the denominator and I set it equal to 0 and I solve, and those are the exclusions or the restrictions. Fabulous question. And that's exactly what we're going to be doing in each of these exercises. I'm going to get my final answer, and then I'm going to look for any restrictions. And we need to make a note that the restrictions, they don't come from the final answer. Oh, no. The restrictions come from, and please write this down. If I were you, I would certainly put this down. The restrictions come from the original problem's denominators, right? Because I had canceled out the x plus 4. At the end, there was no denominator. But that we're looking for restrictions. Look for restrictions in the original denominators. All right, look for restrictions in the original. Will McAllister, did you write that down? I sure would like for you to. Look for restrictions in the original denominators. Okay. Okie doke. Example 2. Y'all are trucking along, doing a great job. Do we already have an LCD in place?
Yeah.
LCD, least common denominator. Yes, we do. Okay. So now, I typically, what I would encourage you guys to do in a problem like this is once you have the LCD, I'm going to make a goofy sound effect. Once you have the LCD, just go right across the top. Okay? Just straight across the top. Every time you get your common denominator, straight across the top. It's easy. Okay? Like 3/7 plus 3/7. Once the denominator is the same, you know that's going to be your denominator, so just go across the top. 3 plus 3 equals 6. It's easy. Okay? However, okay, and here's where my good note takers like Will are going to jot this down. If you're subtracting, don't forget, subtracting a group requires the distributive property, distributing the negative. In other words, I'm going to subtract. It's like that old shtick of mine. Oh, dadgummit, Michael, I'm sick of your rivers, get out. And I take each individual guy out. If you subtract a group, which that's what we're doing, you've got to subtract each term in the group. Okay? So let's see here. What would my fraction look like up here? I got 5x squared minus 4x squared, so that's 1x squared. I got negative 7 minus 1, so that's going to be negative 8x. And I got 3 minus negative 9, so that's going to be plus positive 9. 3 plus 9 makes 12. Let me take a moment and make sure that soaks in. How in the world we got each of those 3 terms from the numerator? Okay, we'll do a little highlighting, do a little color coding with you here. So we subtracted each time. Okay, we subtracted each time, and that's where we got each of these answers. Okay, so check your color coding. 5x squared minus 4x squared equals 1x squared in yellow. Okay, see what I'm saying? Negative 7x minus 1 more x makes negative 8x. And then, of course, 3 minus negative 9 makes 12. All right. Is this my final answer, Sam?
No.
We need to simplify, right? Remember we said that teacher in elementary school would yell at you if you say, oh, teacher, my answer is 4/8. They'd slap you upside the head and say, simplify that fraction. Jack.
Why is it 12 then?
3 minus what?
Negative.
So 3 minus negative 9. Subtracting a negative is like adding a positive. This is a little brain fart. That's all good. Yeah. So in other words, when here's a better way to look at it then. A better way to look at it would be to say, hey, subtracting means change the sign. So if you distribute this negative, what you could do is you could change, and you could say, well, you know what? Let me just make this negative, and this positive, and then you could just tally everything up, and that would be the same thing. But no, Sam's correct. We want to simplify that fraction. Now, to simplify means I need to factor the top and the bottom. Michael, do you think you might be able to factor the top for me, please? X minus 2, x minus 6. I concur. Okay, Jude, you want to factor the bottom, please?
X 6, or sorry, X plus 6 and X. Or no, the X minus 3. X minus 6 and X minus 3.
It shouldn't be plus 3. I wonder if there's a typo in there. Is there a different factorization? Let's think about 18. Because it's not going to be minus 3 and minus 6, because that middle term would have to be minus 9. There might have been a typo in this problem. Let's see. 18, 1 and 18, that's not going to work. 2 and 9, that's not going to work. 3 and 6, that's not going to work. 4 doesn't go in, 5 doesn't go in, 6 goes in, but we've already turned the corner. And if they're both negative. So I tell you what, I bet there's a typo to this problem. Let's change. I'm a teacher prerogative. I'm going to make this 18 negative. Okay, everybody? Everybody understand that? And so now, Jude, adjust your, oh, for Pete's sake, come on. Well, my eraser stopped working all of a sudden. There we go. And then, yeah, that'll change it to a plus 3. That boy. Now, how did I, or why did I need to maybe make that adjustment? What am I trying to point out that's fixing to happen? Yeah. We're going to cancel out, because it's an exercise. Usually with these exercises, you got something that cancels out, right? So your final answer here would be x minus 2 over x plus 3, and we're going to have a couple of restrictions here. What would our 2 restrictions be in this case? We would, again, before we canceled, if 6 was a problematic factor, and if negative 3 is a problematic factor, we need to cancel those bad boys out. So x cannot equal 6 or negative 3. And as Grant pointed out, I know the instructions didn't say, hey, please list restrictions, but we're exercising here. We're practicing. Okay. Y'all feeling pretty decent so far? Sam?
Would you add like each group to like you do subtracting each term by each term?
Yeah, so like in the previous example, that's what we were doing. In the previous example, we had taken and just added all 3 terms together. There weren't any like terms, so we just literally just lined them all up together. But down in this case, we said, oh, look, there's a quadratic term and a quadratic term. Let me combine those 2 together. Does that answer what you're asking?
Okay, so why wouldn't you do like 8x on the top for example 1?
Example 1.
If you're multiplying like each term by each term.
We're not multiplying. Okay, so I think so what type of term is 11x? Let's classify that. That's a linear term. Okay, degree 1 linear term. What type of term is 28? That's a constant term. And what type of term is x squared? That's a quadratic term. So there are no like terms, so that's why we weren't able to combine any of them. This is like an apple and an orange and a banana. They're different. Make sense? Whereas that's a good question. Whereas down here, okay, so we had a banana and a banana, so we said, oh, let's put those bananas together. We had an apple and an apple, we said, put those together. We had an orange and an orange, let's put those together. Okay, beautiful. I think we have time for one last example here. And it's got a wee bit of a deuce piece here, a little curveball action. And I gave you a hint in red. I say, hey, remember about opposites. Okay, so check this out. I'm going to help you handle it. What did we say we needed, Luke Lucchese, to add or subtract fractions? Oh, no. Before we've even seen this example, what did we say it takes to get the 2 fractions? That a boy. Good. So common denominator is required. I don't have a common denominator here, but I'm real daggum close. And actually, Luke answered my next question for me. The opposites are off by a factor of -1, aren't they? So what I could do is I could rewrite this second fraction as m squared minus 1, and I could change and put a negative on the outside there, right? And then that -1 on the outside, instead of being at the bottom, where else could I put the negative? I could put it up at the top or out front in the middle. And then that, just like Jack asked a minute ago, minus a negative becomes plus positive. So we now have a much easier problem. M squared minus 6m over m squared minus 1. And then plus 3m plus 2 over m squared minus 1. Same denominator. We just factored out a negative from the bottom, and then we put it out front, and we noticed, oh, there's already a subtraction, so we got minus negative that changed that to a plus positive. Okay, those two negatives combined together. Now, check this. The denominators are the same, so cheesy sound effect. We're just going to add across the top. All right, and that's going to give me m squared minus 3m plus 2. Again, that idea of like terms. We had a linear term here and a linear term here, so we combined them. We didn't have to change any signs of the second fraction since it was addition. And then down at the bottom, I got m squared less minus 1. Okay? So I need to factor the top. Let's see if, Gavin, you want to factor the top? Beautiful. M minus 2, m minus 1. And then let's see if Caleb wants to factor the bottom. All right, no problem. Let's see. Oh, Gregory's going to do it. Good.
M plus 1 and minus 1.
So m plus 1, m minus 1. That's that difference of squares factorization, right? And we notice m minus 1 is going to cancel out. And so we're left with m minus 2 over m plus 1. And there's going to be two restrictions that we put in place, right? Those two restrictions are going to be plus or minus 1. I can't have the denominator equaling 0. So I would say, look, m cannot equal a plus or minus 1. All right. And so there she goes. Hey, wonderful job today, fellas. Very proud of the effort y'all put in. You're going to have a homework assignment that's not due tomorrow, but you should probably start it tonight. It'll be on Delta Math. It'll be on adding and subtracting fractions. Jack.
Why is it 3 negative 3?
Because the combining of these like terms, negative 6 plus positive 3. All right, live Jesus in our hearts. Y'all be good. Thank you so much. Hey, how's it going, buddy? Sweet. Thank you. Take care. Y'all have a good day. Bye.
Did that go to everybody?
Indeed.
It's definitely on.
Take care. Take care, man. Bye, Will.
No.
Stop my recording.
Here's one.
Yes, sir.
So I forgot to do my AT.